Hi there, my name is Casey, and I'm with San Bernardino County Regional Parks Department. And we're here today at the beautiful Yucaipa Regional Park. Today we are going to talk about geology, or the studies of rocks, minerals, and land formations. Behind me here, these mountains are very unique and special. They are the only transverse mountain range in all of North America. So what does that mean? We'll get to that in a minute. As you may already know, the Earth's crust is divided into large sections called plates. Just kind of like you had a hard-boiled egg and you cracked it. 200 million years ago, the plates were all connected to form one supercontinent that geologists called Pangaea. The study of the movement of the plates is called plate tectonics, and it explains how we form mountain ranges, volcanoes, why we have earthquakes, and all other geological phenomenon. Most mountains run north to south, but these mountains run east to west. That's what geologists call transverse mountain ranges, hence why these mountains are so unique and special. San Bernardino County mountains are also some of the youngest mountains in all of North America. They're only 3 to 5 million years old. They're practically babies, especially when you compare them to the Black Hills Mountains in South Dakota and Wyoming. Those mountains are 1.8 billion years old. To put that in perspective, 1 million seconds is equal to 11 days. 1 billion seconds is equal to 32 years. So the plates move in 3 different ways. The first way is uplift or compressional movement. This is when 2 plates come together and push up. This is what forms mountains. The other way is strike slip or transform. That is when the plates rub together, and that's usually what causes earthquakes. The last and final movement is pull apart or extensional. That's when the plates pull apart, and that is what forms valleys and canyons. Movements of the Earth's plates also help form rocks. Rocks are solid, natural elements made up of 2 or more minerals. Minerals can be very valuable as they are the raw materials used to produce many of the products we use today. For instance, the lead in a pencil that you may use is just graphite mixed with clay. I have some examples of some other minerals. Come with me. So here with me today, I have some of my favorite minerals. Here we have chromite, copper, fluorite, kaolinite, pyrite, and trona. Here I have chromite, the mineral ore of chromium, which is used in making steel and also aluminum products that you find on your automobiles, appliances. It's also used to make chromic acid, which is used for the production of leather that you'll find on shoes, belts, and other accessories. Our next mineral is copper. Copper and some of its ores are used to make brass, bronze, money, like the penny, and jewelry, like the necklace and earrings that I'm wearing today. It's also used in a lot of electrical wiring, so for appliances like the television, your refrigerator, automobiles, and your Xbox. Our next mineral is fluorite. I actually put this mineral in my mouth today this morning, and I hope you did too, because fluorite is used to make fluoride, which is found in all toothpastes. So if you didn't brush your teeth this morning, I'm going to need you to pause this video, go and brush your teeth, and come back. I'll be waiting here for you when you get back. So now that we all have fresh and clean breath, let me introduce you to the next mineral, kaolinite. Kaolinite is a fine, thin clay that is used for the coating in pages of magazines and books. It is also used as an abrasive in toothpaste. What did you know that all these minerals were in your toothpaste? Next, we have pyrite, or fool's gold. During the gold rush, miners would find this pyrite and they would think they were rich, but unfortunately, it holds far less value. One way to tell the difference between pyrite and real gold is to bite on the rock. If you bite into it and it leaves an impression and your teeth sink into it, then it's real gold. And if you chip your tooth off, well, it's probably pyrite. But I don't suggest you go around biting rocks. Now we have trona, which is used for making sodium carbonate and is also used in baking soda and baking powder. It too is also in your toothpaste, but it's also a main ingredient for making bread, cakes, cookies, and all those other delicious desserts that we love. So here are our minerals today. When you take 2 or more minerals and put them together, it forms a rock. So let's go check out some rocks. Rocks can be as small as a pebble or as large as a canyon wall. They can be smooth or they can be rough. Layers of rock make up the Earth's crust. Igneous rocks come from the Latin word for ignite. They're essentially fire rocks. Igneous rocks are formed with lava either underground or above ground. When a volcano erupts, the lava comes out, and when it cools, it becomes an igneous rock. Sedimentary rocks are rocks formed of layers upon layers of rock that are formed over time, usually with water or pressure or wind. Metamorphic rocks are rocks that have morphed or changed from another kind of rock. So they were once igneous or sedimentary rocks, but they are found deep under the Earth's core, where there's pressure and heat changes them and condenses them into a much more condensed rock. It's very rare that you would actually find a metamorphic rock when just walking in your front yard or in your local park. Thank you so much for coming and learning with me today. I hope you can come to one of your local parks and go rock hunting on your own. And just remember, geology rocks!